Hi, prospective student. My name is Sebastian Thrun, and welcome to our Self-Driving Car Nanodegree program. Today I'm here to answer some of your questions for this program and hope can entice you to apply for admissions, because one of the most amazing things we've ever built here at Udacity. I have a list of questions here submitted from various students. The first one is by Michael, and the question is, for those coming from non-tech backgrounds but trying to break into the field, what do you think the best way they can stand out to a potential employer? First of all, you should know the valley is burning for more talent in this field. It's actually amazing how many companies are working in this field, from Intel and Nvidia and Otto and Uber and Google and many other companies. And there's just a huge shortage of people. And the reason why there's a shortage is no one teaches self-driving cars. Universities don't really teach self-driving cars. It's going to take them a decade to catch up. So we are kind of the only ones. Udacity is now the biggest self-driving car educator in the world at this point already, and you can join us and be educated with us. Yeah, when I ran the Google team and we hired people, what was always great is a good technical skill and good academic skill, of course, which you can get here at Udacity if you want, but also a portfolio of interesting things you've done. And one of the distinguishing factors of a Udacity program over a university program is we're very much project focused. So there's lots of projects where you build something, and what you build is something you can show to the potential employer, and employers more and more pay attention to what you've actually built. So you do deep learning, you do sensor fusion, you do localization, path planning, controls, and these are the things that employers directly want to see implemented on their cars. In fact, to be quite truthful, if you do deep learning these days in Silicon Valley, you should really find a job very easily, because it's such a hot field today and there's so few people who understand it. So to stand out, to answer your question, Michael, to stand out, I'd say take the program, build your product portfolio, and then work with our careers team to make sure that your product portfolio is well curated and your CV looks great, and we will do our very best to help you find a job. Second question is from Viper, I think from India, I assume, because the question says, what are the career prospects for students of developing countries like India, where there's no self-driving car industry yet? So it turns out there's a car industry in India, there's one in China, there's one in Brazil, one in France and Europe, and all these companies eventually have to go into this field. So I know from China in particular that companies are desperately hiring in this space right now. And it might not be quite as flashy as the Waymos and the Nvidias in the world, or the Mercedes, but typically what happens in the world is that Silicon Valley leads the way and hires first, and then companies around the world hire similar talent. So we've been working with companies around the world placing people in this field. And I would say, even though there isn't quite an industry yet, you always want to kind of get educated today for the job of tomorrow, not today for the job of today or the job of yesterday. This is something that's rapidly growing with enormous demand around the world. So I would suggest do it and try it. And quite frankly, even if you can't find a job in the self-driving car industry, there's now so many robotics companies and industries around sensor fusion and Internet of Things that you require similar skills, that I bet you can leverage that skill set to adjacent fields. You will be in demand, is my prediction. Dimitri asked the question, what are the key unsolved challenges in autonomous driving today that holds us back from getting from level 4 autonomy to level 5 autonomy? For those of you who don't know this, level 5 is the one where you can just fall asleep and wake up 2 hours later and still be alive. With level 4, it still requires occasional human intervention. Level 5 is the dream, of course, of what we're doing. It's the holy grail, and quite frankly, we're not there yet, which means you can, as a student, you can make the difference. Come to our Nanodegree, enroll, learn the skills, and change the world. I'm jealous because when I started self-driving cars, there was no Nanodegree program. I had to teach myself. Now you can get a much accelerated path in your life by joining us. But here are the unresolved challenges. The real difficulty in self-driving cars is this long tail of unlikely things. It's like the couch on the highway. It's the mattress. It's the deer that crosses the road. It's the flat tire that you run into unexpectedly. And in totality, every year you as a human driver experience exactly one of those things, then it couldn't be level 5 autonomy, because you can't have an accident every year. So we have to get to this point where these very unlikely things are still being handled responsibly. The good thing is our cars are becoming better and better every year. And as we drive more and more, we get more and more examples of these very unlikely things, and we can knock them off. And with the advent of deep learning and machine learning, the speed at which we're able to knock them off has actually massively increased. So the nice thing about computers is the more data you accumulate, the more you can knock off. And unlike human brains, when we pass away and our kids take over, they have to learn everything from scratch again. In computer land, you can just keep the data and pass it on to the next generation of cars. So even the unborn future cars can benefit from today's experiments. Having said this, we need more people like yourself to join in this. We need smart people, dedicated people who are willing to go the extra mile, learn the skills, and then build bigger data sets and leverage more machine learning to get to this point. Because when we get to this point and we have level 5 autonomy, it's going to be a complete game changer for the world. That means we can share cars in a new way. The car can come to us empty, pick us up, go somewhere else. That means our downtown areas will have no parking spaces anymore because all the cars are just busy driving people around. It also means transport will be safer. We're going to probably save 1 million lives every year and be much, much more affordable to people. So that's the vision of why we're doing this. Marcus is asking the question, what are the biggest market for software developers for autonomous driving and who are the technology leaders? Every person knows way more on Google as the leader in this field. There is a whole bunch of great OEMs who've really pushed hard and have amazing technology. Mercedes is one of our hiring partners, BMW, Toyota, Ford, General Motors. Around the world, companies, Nissan, are now gearing up and making enormous progress. Hand in hand with those are tier 1 suppliers, which I think companies you don't talk that much about, but they do amazing work. Bosch and Continental, Delphi, and many others. We just saw Mobileye being sold to Intel recently as a supplier. There's enormous progress. And there's chip companies like NVIDIA, Intel, that push the same boundary and have made this a strategic goal. In fact, I can tell you at NVIDIA, one of our other hiring partners, self-driving car is one of the most important corporate goals. And then, really interesting for me is ride-sharing companies. As you know, we have a competition with Didi right now running for $100,000 to build a self-driving car technology. Didi is the world's largest rideshare company, much larger than Uber. But even inside the United States, Uber's ATP is working with Udacity as a hiring partner, and of course Lyft are companies that really understand if someone invented a level 5 self-driving car, it would be completely disruptive to their business. So they've all prioritized self-driving as the #1 strategic objective for their company. And that's really important. If you look at recent acquisitions in this space, from Cruise being sold to GM or Otto being sold to Uber, you can, just by the magnitude of dollar amounts, really read off how desperate and how the industry is to make progress in this field. It's a big race. It's like the race to the moon, the race to the self-driving car. So if you come and join us and take your time in May to enroll and apply and finish your studies and get the Nanodegree certificate, then my suspicion is you won't have a hard time finding a job. Matt is asking a question. Here's the question. How well do the projects and skills developed in the Self-Driving Car Nanodegree transfer to roles in robotics and automation? Quite well. So if we look at the core things we're covering, deep learning, sensor fusion, localization and mapping, controls, and path planning and systems integration, these are the core project areas. These topics apply to anything robotic and even beyond robotics. If you go to smart buildings, Internet of Things, wearable devices, devices equipped with sensors, biomedical devices, heart rate monitors, intelligent hospitals. The commonality of these is that you have a flood of real-world sensor data coming in that has to be processed, and then decisions have to be made based on that data. And that's what self-driving car is all about. Now, I don't think if you want to do general robotics, we have other nanodegrees at Udacity that might be a better fit, because this one is specific to cars. So you will learn and implement things on a car platform. You work with a car simulator. We even have a physical car at Udacity where at the very end you get a chance to run your software on those physical cars, which is very cool. But the general skill set, AI, controls and so on, is very broadly applicable. And we live in a world right now where I think physical intelligent devices will become the next big revolution across many industries. So if you enroll in this car nanodegree, it's primarily for self-driving cars, but I think the skills can be leveraged into many other fields. Marcus is asking an interesting question here, which is close to my heart. How much of the problem, in this case self-driving cars, do you think can be solved with machine learning, and which parts rely on systems engineering based on manually crafted decision making? Now, When I grew up, there was no machine learning really of any scale. And a software engineer would write on this very meticulous kitchen recipe, often millions of lines of code, for every possible contingency. I would argue the single biggest innovation in computer science in recent history has been the advent of scalable machine learning. We're now at the point where a well-trained machine learning system can replace human dermatologists in fighting skin cancer or can play Go better than the best human player. And it's a matter of scale. And to me, this really means we're flipping from a world where a human engineer has to handcraft every rule to a world where we can teach a machine and the machine finds its own rules. So the machine becomes its own programmer, so to speak. That is, of course, not a binary switch. We still have to architect a lot. But as time goes on, I think we're going to rely more and more on data science and machine learning and experiential learning for the machines to find their own rules. As this transition occurs, our machines will be infinitely more competent. If you look at the recent progress in computer science, from the way, lawyers work in terms of using leverage machine learning to find legal documents, or doctors work in radiology to read chest x-rays to understand whether there's a cancer or not. These things are now more and more empowered by machine learning, and as this progresses, the capability of these machines has really exploded in a very positive way. So I would say, to your question, it's not a binary question. We still have to architect, but over time, the machine learning component will be more and more important. Jesse Hughes asking a question: what is the role of academia going forward for autonomous vehicles? I'm going to be careful not to upset my friends from Stanford and Carnegie Mellon, but the reality is, at this point, the major progress in self-driving cars has actually come from industry. And the reason is, I ran the Google team for many years, and we were afforded a level of freedom and a level of scale at Google that I was never able to muster at Stanford. When you look at education right now, I would actually argue not as only is this program, the self-driving car program at Udacity, the world's largest programs in self-driving cars. In fact, we train more students right now than all universities combined. But we also benefit from our close corporate partners like Mercedes and BMW and NVIDIA and many others who've helped us build this curriculum to make it really kind of bleeding edge. We are so incredibly in front of everybody else because we can build this curriculum much faster than universities can. Of course, universities are great places. I teach at Stanford myself, highly recommend them. But if you want to have the latest skills on self-driving cars, I would argue this Nanodegree program is the place to be. Okay, here's a student named Otto, not to be confused with the startup company of the same name. And he's asking, will an open source self-driving car stack ever be as prevalent as Linux? Boy, possibly. Obviously, at Udacity we're building one, and there's several others now who build OpenStock. Baidu just announced it, and there's another startup in San Francisco, which is one of our partners, Comma AI, is also working on it. Linux is incredibly prevalent, and it's been around and it's been vastly used. I would be careful to think of it as quite as prevalent as this, maybe at some point. Impactful, yes, because we lose something like 1 million people every year on public streets and traffic accidents. And I think if you're able to bring self-driving car technology to every car, we could conceivably cut this number down to like 10 or 5% of what it is today. So I think it's important. These are the early days. We don't quite know how the industry will shake out. Will Waymo take everything over by the fact that they are technologically superior right now and license it to car companies? Or will an open source stack, Android-like, win in the end of the day? It really depends how the various players are playing their cards. But that's the fun part. And that's the reason why you should be in the program right now, because it's early and you can influence these paths by your own work and helping us building a better open source repository here at Udacity. So enroll or apply and then help us build the world's best technology. It's up to you. Here's a question from Lam. What do you think about a kit that can make almost any car fully self-driving? I think a kit is a good idea. The thing to worry about in the kit case is it's actually not that easy to build a good kit. Many cars use, for example, a hydraulic steering booster where you have a liquid being pushed in the system to assist you in your steering positions. Or many cars use hydraulic brakes. And to interface with those, you have to mess around with kind of hydraulic systems. When we build a car here at Udacity, we use brands like Ford or Lincoln who have a relatively simple steering interface. It's all electric. So you can just snip some wires effectively and and funnel your own digital message in, which makes it much easier, much safer. If you ask me what's going to be the future going to be, would I want to build a kit company? I would be hesitant with a kit company because likely you can only build a kit for a certain type vehicle, maybe a Honda CR-V or something. It'd be very hard to build a kit for every vehicle. And then on top of it, you need to then kind of convince people that your kit is safe enough for all these cars and that you have worked through the integration. To some extent, it's actually easier if you focus on just one car. And then the more likely model would be that you either use this car as a taxi and buy many of those and deploy them, or try to sell these cars or work with the OEMs and sell these cars directly to end consumers. Also, quite frankly, cars turn around every 10 years, right? So in 10 years from now, people will have a new car on average. And maybe if it takes another 2 or 3 years to get the technology working, then 10 years from now, anybody buying a car gets a self-driving car automatically. That would be great. It's a question from Chris. If you were building Junior now, what would you do differently? Not Stanley, but Junior. Obviously, in Junior's case, for those of you who have a long history of memory, Junior, about 10 years ago, 2007, participated in the Urban Challenge, won second prize, not first prize. I was distracted. I was building up Street View at Google at the time. And the reason why I won second prize is we had a software bug. It took a whole bunch of detours that cost us a lot of time. I would probably debug the software a bit more. In Stanley, what we accomplished is we had a software freeze a month before the race. And then we were able to eliminate 4 or 5 major bugs just in testing. In Junior, we weren't quite as disciplined. We had the software modified pretty much the day off, and that unfortunately cost us the first place. But we also had amazing competition, to be honest. I mean, Carnegie Mellon is just a great place and had very strong people. Chris Urmson was just really, really strong. But in total, I think what we kind of originated back in the day was the use of machine learning. And it wasn't quite as grandiose as deep learning today, but both Stanley and Junior had a massive machine learning component. And at the time, we were about the only ones doing it. Today, even past my Google days here at Udacity, what I find is that deep learning is just incredibly powerful. So if I were to do it again, I would probably toss out a lot of the geometric stuff and really move much deeper into machine learning as a way to make the car drive better and do much, much more of that. Here's a question from Ashraf, a really good question. Is there safety criteria for self-driving cars that determines when technology is ready for the public? I'm tempted to say no. Even though there's norms, there's an ISO norm that specifies how you have to develop software called ISO 26262, that if you follow it, you have a certain assurance and the quality of your software development process, but it's not an assurance of that the car is actually safe. My take on this is we still have to develop good metrics for safety. Part of those will require extensive testing, and you can help us actually as a student in a Nanodegree program think about this and brainstorm and do projects in this space. One is extensive testing. We just statistically show we run, I don't know, 1 million miles, and in 1 million miles it didn't crash. This is what we did at Google. The second one is also things like cybersecurity, like is it safe towards hackers that will break into the system? And we've recently seen that even regular cars can be hacked, and there's been instances where academic researchers proved that you can go into a commercial vehicle and disable the brakes, which is very, very dangerous. That ability to hack into systems will obviously be reversed with self-driving cars because there's a much, much bigger software interface. So one thing that we have to prove to ourselves is that. It's the early days. You're going to join something that's very new. You're going to join something you're going to be a pioneer of this field. And as a result, many of these questions haven't been answered, which also means that companies will hire people to answer those questions. Anyhow, join us. Question by Samuel. Do you think self-driving vehicles are more likely to lead to more ride-sharing or more individual transport? I have a very clear answer. I believe the future of this is ride-sharing. Just imagine the following. You have a car that you want to get. You go to your phone and you get to your Didi app and you push a button and up comes an unmanned empty car driving to you. And you hop inside. You might either drive it yourself or you might just be driven around by it. That means that we can reduce the number of cars needed and have much better car utilization. I did a lot of math on this one, and relative to the costs of an UberX, you can expect a cost reduction between 60 and 80%. It's a lot. Typically, say a third of the cost. So if you currently In New York, and the average Uber fare is about $10 or $12, say $12, then you would get the same ride for about $4. That is cheaper than a bus, turns out. It's a big inflection point, and I think costs matter a lot in this field. By getting rid of the driver, which costs a lot of money, you make transportation really, really cheap. So in that sense, I envision this future where the car is just utility. Today, your car is being used something like 3% of the lifetime and parked 97%. My car right now is parked for the waste. In the future, cars might be able to operate 50% of the time or so. As a result, be 10 times as efficient in serving people. So we need only 10% of the cars. And that means we have a complete change of cities, there'll be no parking garages. You can drop yourself off in your favorite office. You can even go around drunk. And I think that vision requires ride sharing as the core. So I would put my money onto ride sharing, not onto owner-operated cars. But who knows what's going to happen? From Jose. Thank you for making the barrier to entry $2,400 and a PC and an internet connection. This is mind-blowing. Thank you, Jose. Sometimes people respond different to this. How can we lower the barrier to entry even more? I wish we could do this without charging any money, obviously, but we've worked really, really hard to get to $2,400, and it's a small sliver of what you pay at any US research university. It's still a very high barrier to many people because there's a lot of money. And I wish we could do it for free, but I can tell you the services you're going to get, the personalized feedback, your mentor, the information, the content you get, and the projects hopefully make it worth your $2,400. We know it's a lot of money for you. It's a lot of money for me too. So we try to do our very, very best job here. Udacity's mission is to democratize education. I have the privilege to be a professor at Stanford and before at Carnegie Mellon. And as a result, I had the privilege to partake in amazing education. And that is a privilege of very, very few people. In the United States, we pride ourselves on the best university system in the world. But we often forget that this system is only accessible to a small number of people. We are extremely proud that something like the Self-Driving Car Nanodegree program can reach anywhere in the world where people have internet connectivity. And while it's still expensive in many ways to many people, at least now we can go to the Middle East, we can go to Africa, to South America, to China, to India, to Indonesia, and really help people get what we consider the best education on the planet. So help us fulfill this mission, spread the word, come to us, apply, enroll, help us improve, critique, give us negative feedback if need be so we can become better. But make this motion of making education available become part of the movement. The reason why you should become part of the movement is for yourself, to find a better job, of course. But also, I firmly believe if we can bring good, high-quality education to everybody in the world within internet connectivity, then we can really help the world doubles its GDP. I think there's many, many super talented people in places that currently have no access, and you might be one of them. And Udacity wants to change this. So I want to thank you for listening to me. I want to encourage you to apply. The application deadline is actually this Monday at midnight Pacific time, so it's very, very soon. And get in, and then, honestly, explore the beauties of a technology that is just really, really amazing. I've been spending last 12 years of my life on self-driving cars. I wouldn't want to miss a single second. I hope it'll be the same for you.